Okay, so last week we started discussing about this Pytorch workflow, where we go through a lot, and let me recap that so that we can, build on this session tomorrow and continue with that. Pytorch workflow. Okay, so we understand we did the fundamental of PyTorch, knowing some how to do some operations, but when doing PyTorch workflow, this is the idea we mentioned last week. The first thing is when you have your data, whatsoever the data is, you need to change it into tensors, turn them into tensor, build or pick a model, and now feed the model to the data, evaluate and improve through implementation, experimentation, and save the model finally. These are some of the steps they go through in this notebook. So here we made an example saying, okay, let's import Torch. Let's import something called NN, which is neural network. And now here we do that. So here they want to create, synthetic data. I'm just recapping this. We understand this last week. I'm trying to create a synthetic data here so that we will be able to, build some kind of intuition about how the deep neural network works. So as I explained last week, today that we have some kind of weight. So here we have, linear regression. We know our linear regression is y equals mx plus b. M is the weight, x is your input, and b is bias. And what we want to do is basically we want to, try to predict given x. So here we create an x. So let me do this. So here we create an S. And when we create the S, if I do this, we can see, is it the, okay, no. Let me see something. I have, it seems I have another workflow notebook. Okay, I think this is the one, but I, let me, okay, all right. I thought I have another modified workflow. Anyway, no worries. Okay, no worries. Okay, so we already know when we want to train a deep learning or machine learning, we need to have our features, and now we need to have our target, right? So here we just want to use some toy example to show how we can do that with basic neural network architecture. So here we have our X here, and now here our X. So we can see here, this is our future vector. And before we, if I have not on speed this, when I create this, I have this. So you can see this is my tensor. This is just a tensor, but I want to create a future where I want to have, a matrix, one future vector with everything. So here you can see I unsqueeze it. So here it means I have one single future with different observation. Can you see that? So this is some of the essence of doing unsqueeze. And now here you can see already I have my, let me delete this guy. And yes. Okay. Then y is equals to weight times x plus b. And now when I run this, it means I have my y again. So if I run my y here, I can see this is y, right? So we already know that if you are training deep learning, you must have your future matrix and you must have a target. So this means I have my future matrix, which is only one future, and the corresponding target, meaning like, given 0, 0, 0, what is the corresponding is 0, 1, 0, y, the corresponding y. Why? What is that? Because given x is 0, 0, we have weight and bias. So you can see if you multiply by weight is 0.2, 0.2 times x. If x is 0, it will give you x, plus bias is 0.1. So you can see y will be 0.1, because that is why given x is 0, that is x 0 here, x is 0, and your weight is 0.2. So 0.2 times x plus bias 0.1 will give you 0.1. That's why you can see why we have 0.1, right? So this is just, we build synthetic data. Like, let's try to build a model that given any this, can it predict this is the value? Given this value, can the model predict this is the value? This is what we are trying to build synthetic stuff here. So now, but how can we do this with deep learning, Pytorch? Because in machine learning, if you are using support vector machine, you just need to pass this, your y, this is your future. We also need to use this kind of neural machine learning algorithm we are familiar with, which is like support vector machine, whatsoever algorithm. We just need to call it because we already have our future. We already have our future. We already have our target, but we want to use deep learning. In particular, we want to use Pytorch. Now, how can we do that? So this is something that we want to show. So here you can see I think this is, let me see something because okay, because this is the original notebook, because I already modify it, because I don't do this split. I just change this split to scikit-learn split, train test split. But this is what this code is basically doing, is trying to do trying to divide the data into train and test. We already know that you can use train test splits from scikit-learn, but also this one is still the same. So here we have X train, Y train, X test, and Y test. So they divide the data. They want to train a machine learning a model. So here we have our training data from this. So here, remember, this is the target, this is the futures, and now we take some sample to assign them into train and stuff like that. Okay. Now what they want to do now is they want to create a function. They just create a function now to basically use the function, call the function plot prediction. You can see the plot prediction. We use the original data here, the X, given X and Y. We use them, and we can see here, this is what is happening. This is this yellow, blue lines. We can see the blue lines. They are the training data. This is the training data, this training data. And, the red line is testing data. So here you can see we have our, train, Y train, test, but because the train and test data, they come from this original value. So that's why we can see the training and the test, they are in the same, they fit into the same line. You remember in linear regression, we want to fit the same thing. Now, what we want to do is now we want to use Pytorch to try to predict, to give it a training data, and now try to predict these lines, this point, whether they can be here. So sometimes they will be here and they will be here. We'll fine tune the weight. As I told you, this is very important. As I told you, like when we are doing the plan, we do prediction, we compare with target. If there is different a lot, we update the weights and now do another prediction. So this is the central idea here. They want to show us this updating the weight and going back. But here they just create a function because we don't have prediction here. We haven't done any prediction, but we are plotting the original data here. So let's go on and now do that. Okay, so last week also we do recap about Python function and Python classes. Remember all those stuff. We are not going back to them now. Okay, so I believe we all remember Python classes. So here we are trying to create. Remember in machine learning, you just call your classical machine learning algorithm in scikit-learn, maybe SBM whatsoever. You call these algorithms. So they are implemented also in this kind of similar ways. They are just classes, right? So here we want to create a class called linear regression. We want to create a class our own called linear regression. that can do, prediction. But we made mention in Pytorch last week that we have what you call NN module. So any class must inherit NN module. Any Pytorch class must inherit NN module. So here we, this is a linear regression class we want to create, and now it must inherit this NN module. So we are initializing our weights here. You can see the weight. You can see self.weight. If you already know. So here we have the, init class. Last week we, if you are not here last week, we recap what is classes in Python, how to do inheritance. If you are not here last week, you can watch the recording, because going forward, what we'll be implementing is basically using classes. And if your Python is rusty in terms of classes and function, you find it a little bit cryptic. So I will urge, we go back if you need to refresh that. So here we can see we have two variable. We have weight and we have what, var-x, right? Now, how do we can see here we have init function, and we know each and every class must have init. We already know this in our previous, and now because this linear regression is inheriting from NN module, so we have super init, right? So this is telling us this is inheriting some stuff like that. So here you can see we have self.weight. We are trying to initialize our weight here, the weight we have, this weight, and we will initialize this bias as well. Then we do this stuff. So let's go back. I'm repeating this one because we already did it last week. So here, self.weight. What is self? Remember, if you want to initialize a variable, instant variable in the classes, it must start with self. So that's why here we say self.weight. And now inside NN module has what we call NN parameters that can be used to initialize, your model parameters. So these are the parameters we are initializing here. Can you see this is weight? And after the weight, we have bias. So let me show us neural network weight and bias. Yes. So you can see here we have a neural network here. We have your input, which is X. Can we see that? But you can see we have weights, and we have what we call bias, right? We have what is called bias. So this weight and bias are parameters of your neural network. They are parameters, right? They are parameters. And this one, X, is something that you feed into your neural network. So you must define this weight and bias in parameter session here that we are trying to do. So you can see here, we are trying to weight equals NN parameter. We use rand n, so we want one parameter, and we initialize something required grad equals to true, and the type of the parameter is, float. What this is saying is that required grad equals true. It means, activate what we call, it will be used for gradient descent. So this is some theory. We'll come to that, but we need to, okay, in a simple step, when we say required grad equals true, it means we'll be able to update this weight. Remember here, I told you when we are doing deep learning, we have our X and we have our, we initialize our weight. It goes through here, make a prediction, and now compare the prediction with original target. If the value is quite low, the difference is large, we need to update the weight. So now if you declare your weight to be true here using required grad, means required grad equals to true, it means you'll be able to update the weights. You will be able to update the weight. If you set your required grad equals to false, means you will not update your weight. And what is very important in deep learning, training deep learning, is we are trying to optimize the weight. We are trying to find the perfect weight that makes our neural network good. So that's what we have here. So yeah, and also the bias, we update here, we say required grad equals 2, and that's, define our parameters here. And here you have your input X. This is what we call forward pass. Coming into here, we are calling forward pass because we are making prediction. Now, going here to update the weight is called backward pass. So in neural deep learning, this coming this way is called forward pass. And now here, because we initialize our weight here, so this one here is just initializing your weight, only initializing your weight and bias. You only initialize your weight here. That is the essence of this, part in this one. But we must have a forward pass that is making the prediction. That is given weight, given bias, what is the the prediction? Can you see this one? The function activation, something like that. So given bias, given weight, given input, it comes here. Summation, summate all this bias, some weight, some AYX, make a prediction to get Y. So this moving this direction is what we call forward pass. So this is what we want to do here. Can we see it? Forward pass. And if you remember here, you can see here what it takes. It takes the summation of these values, right? So here we can see we have self, we have X, right? The X, because this one takes X. Going this one, it takes, because we have X, it must be imputed here. It must take the B, it must take the Y. Wait, so you can see forward pass, it must have the X and it must have the weight and bias, but we already have our weight and bias here. We can see our weight and we have our bias. And now how can we, because we are doing linear regression for you to do, it just to say self.weight, right? Weight times input plus bias. So this is what we do. So meaning forward is we'll do this calculation. So in essence here, what we have is we have initialize our parameters. Don't forget, this is basic what we do, but here we do it like, you can see you initialize your weight. This is your weight and bias. And now moving forward is you said weight times X times bias, right? But we want to implement this in Pytorch. That is why we have this. Yes, so this is called forward fast. So that's what we have. So when we run this, it means we have this. Any question before we move on? I'm repeating.
My question.
Yes, go
on. Since we implement forward here,
yes,
does that mean required grad is the one that is doing the backward, the
yes,
back propagation?
Yes, it optimizes.
So we don't need to implement.
Yes, exactly. Good question. Good question. Because that is one of the powerful features of Pytorch. It abstracts all those back propagation. When you set grad equals to true, then Pytorch is doing that for you automatically. Yeah.
Doc,
yes.
Hello?
Yes.
When we are updating the weight, does that mean that the bias is constant? It doesn't change when the weight is updated?
Because here, I think because here we already set it also to grad equals true, so we also update it as well. We can see, can we update the value with we also know what is called gradient descent. So here, this is actually what is, gradient descent. I don't know if you know gradient descent, but the theory behind it also will come in. So yeah, we are also updating everything, the weight and bias. Yes. Okay. So now here we have this. Let's go on. So here, this is an example explanation. This is just trying to build, just get the intuition. We'll come to where you will get understanding everything, but here we are trying to build the intuition. If you don't understand at this step, you'll understand it when we come maybe tomorrow to the next step. We'll have this one, but yeah. So you can see this one here, they are explaining everything. Here you can see subclass model. So each class you want to create in Pytorch, it must subclass. It must be the parent must be NN module, because here you can see we call NN parameters because it's from NN module, and you can see yeah. So here you can see initialize model parameters. So you can see here is initialization. You initialize model parameter. We know that models do have parameters, so this is how we initialize them. Why do we use torch rand n? Because we want to create a random number, which is only one random number. That is why we use torch rand n. But torch rand n has some parameters. That is torch rand n has some. If you go here, okay, let me show us here. Torch rand n. No. Okay, so let me use this. Touch dot rand n. So let me show us something here. You can see when you create a tensor, we say touch rand n. It has a lot of parameters. Required grad, you can see by default is required grad is false because you don't want to, do anything. But when we want to, go for, because that's why previously when we create a random tensor, we just don't use any grad, So when you say required grad equals true, it means you want to. So these parameters that we have required grad, data type, you can see the data type, data type none is also part of how you create your tensor. So when you create your tensor, you can specify even the devices, you can specify the whether it require grad equals true or not. So yeah. So here also we initialize our parameter, which is bias, and now here a subclass as well of every subclass of any module must have a forward method. So here we have a forward method that override NN modules forward. So here this is basically the structure of that. So you can see here we create this class. Now we can have this here we create random seed and now linear regression model, because this is what we create. Remember, linear regression, we want to create object for that. So linear regression, we can create a model called model zero. So within linear regression class we create a model zero, and now we can look at the parameters of the model. We can see here we have the parameter, one of the parameters, and we can see we have the parameters, two parameters, right? The first one and the second one. Any question? And we can see, we can even ask what are the parameters. We can see this is the weight and this is the bias. So here we build our Pytorch class that can be able to, calculate, make prediction. Any question? Okay, let's move on fast and we close. So now we create this forward class. So remember, you can see the forward class now is the one that will calculate this to make it will return this multiplication, which is equals to y. We can see y equals to mx plus c. So here, when you call this linear regression, what it will return at the end of the day, you can see return is it will return this result. It will return this one. So yeah. So here we want to make some kind of toy stuff, which is making inference. So we specify the linear regression, how to make the prediction. So here we have some kind of inference here. This so with touch inference mode, YPRED. So here we already create our model. What is our model? You can see this is our model, right? Model. We create our model using linear regression object. You can see that, because look at it here, linear regression. This is the class. So when you want to create the class, you need to call this linear regression like this. And now we have our model, it's called model zero. And now here we can see the parameters. Now, how can we use how can we make prediction with this model now? How can we make prediction with this model? So this is what we want to say. So here model, given X test, can we see X test? What is the YPRED? So what is X test? Given YPRED, so what is X test? Look at this one, X test. Can you see X test? We already have, you remember, X trend. We already have X trend, Y trend, everything. So this is X test. Now I want to create a prediction with that. I want to, given this, what is the prediction? So this is just doing like this. This is the X, given X test. You already have your weight, you already have your bias, then it will return the Y, which is basically linear regression. So this is what is happening here. Model, because we already create the model. So when we run this, Now, what is the Y? So we can see our prediction. The Y, it gives us this. So we can see this is our Y, given the, okay, no, Y pred. Sorry,
Y
Y
pred.
So this is our Y pred. So given X test, what is the prediction? Y pred. This is the Y pred. Now, so since now we have our Y pred, we want to try to see that does our model now be able to align this. This is the original one. Okay, let me run this guy. So look at what happens now. You can see now our prediction. The prediction, this is a line we predict. This is original data. Can you see the original data?
Yes.
So you can see it predict it here. So this is a prediction. Given we give the model this testing data, X test, we just give the model this testing data. Can you see that? We give it testing and say, give us the prediction. Now, when he gives us the prediction, we try to figure it here. Then the value is here. So it means it does not make a good prediction. So now what you need to do is to run more by updating the weights so that the weight will now, let's see it again, train a model. Yeah, so you see the first thing here we did, like, you know, it predict here. Now, how can we train a model so that this model will learn, will try to find what is the distance between here? That is what I was showing you here. Now, how can we now use the model to find out the difference between the true and the target? You can see we need to find the loss. Then when we find the loss, we need to update the weight, and now trying to keep doing this. Now we need to have something called optimizer. We need to have something called loss that will try to find the weight, the difference between the prediction and true value. Is that correct? So this is what we're gonna do here. That is how can we train a model. Here, we have not trained a model at all. We just make a prediction. We have not trained it because we just do one pass given weight. Now, how can we now train a model? So here, this is you know, his example here as well. You can see this is the true values. And now when he makes a prediction, look at the where the prediction is. So it means there is a difference between the true. Now we need to find the distance here. That is the true. That is the prediction. What I'm telling you here, the true target, the prediction, find the difference between them. Now, how can we find the difference between them? We need to find the prediction minus the test. You can see, give us this. Now, and now with this value, we go and iterate. So this is what we call training. Make a prediction, find the distance between them, update the weight. So how can we do that? We have what is called in neural net, in Pytorch, we have what we call loss. So this loss is the formula that find the distance between this guy and this guy, define the distance. And so we can initialize it, which is called MAE, mean absolute error if you are doing regression. So we can call it NN the loss. It's called L1 loss in Pytorch. So this is called L1 loss. So when we create this, it's called L1 loss. So we have the loss function now. Now, how can we now we call, with this loss function, this one NN loss, will create the difference between the prediction and true value. Now, how can we now go back and do optimize this and change the weight? Now, this is what we call optimizers. We're going to use what is called SGD optimizers, stochastic gradient descent. That is optimizers. You can see optim.sgd. Now, for you to define the optimizer, you need to give the model the parameters. We need to give the optimizers the previous parameters. What are the previous weight and the weight? Now, when we want to define the parameters, optimizer, can you see optimizer, what I'm telling you here? Optimizer. So for you to tell the optimizer, change the weight, the old weight, you need to give it the old, previous weight. So that's what I'm doing here. Touch optim.sgd. So we have many optimizers. Touch params. Can you see one argument, params? That is model.parameter. You are giving the model previous parameters. And now here we have what is called learner rate. This learner rate is telling you how much are you going to change the weight. So if the weight is 0.1, are you going to change the weight to 0.5, 0.6 or 7? How fast? So if you have small learning rate, 0.01, it will nudge the weight. Maybe if it is previously 0.8, it will not nudge it to maybe 0.81 to nudge it to small. If you give the learning rate very large, it will nudge it from 0.8 to 0.12, large one. So we have what we call learning rate. How much optimizer should change the parameter at each step? Can you see what we mean? This is really important, this step. If we understand, if you don't understand this step, please ask question. Yeah, so I just want to compare these things so that it will make you know, and we us to understand better. Yeah, so it's time for Salah. Oh, okay. We can go for Salah. I think we can continue tomorrow. So, but the basic idea I want to tell you, if we will come back to get tomorrow here and continue. The basic idea I'm trying to tell
tomorrow? You that, yeah. Okay.
A question?
What I'm saying, Doctor.
Yes, what you said?
What we are doing now, we are just trying to understand the science behind all what we are going to. Since I think for Pytorch, since I have never used it, we are going to use some APIs.
Yes, exactly.
Like,
Yes. So it's better for us to understand what we are doing behind the scene, behind the hood. So that's why I'm trying to show this. It will be easier for us after, but it's good to understand this. Yeah. So given any input here, make prediction, your true target, find the loss. When you find the loss, now you optimize the weight. So here, you know, this is a loss, this loss, what it find the prediction and the true target, you use this loss. So in Pytorch, if you are doing user regression, we use L1 loss. And now, how can you tell optimizer to change this weight? So we use touch.optim, this SGD, we have different optimizers. Now you need to give it the previous parameters, and now you give it to the learner rate. So when we run this guy, let me, okay, I think we can stop here. It's already prayer time, and we can continue tomorrow. And inshallah, tomorrow we will, when we get this basic in Pytorch, we have a single training loop. So when we understand this training loop, you will we will not change it to the whole of the you know, Pytorch training loop. So I'm trying to take the training loop one by one to let us understand as it is here how it works. Tomorrow, inshallah, we'll continue, and we'll understand, like now tomorrow, when we train and update our weight and parameters, we'll see that this prediction, it may now comes maybe somewhere here. We'll update the weight and parameter until it comes closer to here. So we are trying to build the intuition, what is really happening in training and updating the weight. Okay, so I think we can stop here and continue.
Doctor, don't forget to share that book before.
Sorry, you say what?
The book, the deep planning book.
Okay, I will share it in the channel, inshallah. Malama Sa'ada, kina nan dama?
Ina nan da.
Ai ba a jin ki hajiya. Ba kya ka mana contribution. Muna ta asking questions.
Ana ta mas.
Okay. So yeah. So Allah ya mu gobe, inshallah we continue tomorrow. You know, we are trying to build the intuition. If we build this intuition, then the subsequent one, we have a single training loop for Pytorch. We will not change it in the future, but it's good to have the intuition. Okay, inshallah, we see tomorrow. Bye-bye.
Thank you, Doctor.
Mm-hmm.